Now, when looking at definite integrals that require u substitution, we have to be especially careful with our treatment of the bounds. To start this one, we're going to look at what our substitution should be first. So we're going to let u equal the square root of x, which is of course x to the 1 over 2. I'm going to take the derivative of that to find du dx, which is 1 over 2 x to the minus 1 over 2. For the sake of consistency and being able to spot the appropriate substitutions, I'm going to write that as 1 over 2 root x. Okay? Now, I want to know again what to do with dx, so I'm going to solve by bringing the dx to the other side. Now, the only difference between what appears in the integral and what I have with my du and dx over here is this extra 2 in the denominator. Okay? So the way we account for that is we can stick that on the other side, multiply both sides by 2, and now we get an exact substitution because we have a 1 over root x dx here, we have a 1 over root x dx in our integral, so we're going to replace this 1 over root x dx with 2 du. We're going to replace this radical x with just u. And now the question that remains is, what do I do with the 1 and the 16, my upper and lower bounds? And so you have two options. You can either revert back to x once you've taken the antiderivative with u, or you can change the bounds now. I think it's usually less work if we change the bounds now, so we're going to do that. If x is equal to 1, what happens with u? Well, u is the square root of x, so u is going to be 1. And similarly, if x is equal to 16, u is going to be the square root of 16, so u is going to be 4. So when I rewrite my integral in terms of u, I'm going to go not from 1 to 16, but from 1 to 4. And then we said the radical x gets replaced with u, and the dx gets replaced with 2 du. So we'll write it like this for now. And then we'll stick the 2 out front to make it a little bit easier. Okay, so now I've got a new integral in terms of u. Bounds are set up in terms of u, which means I can ignore all the x stuff that was there to begin with and just evaluate this definite integral. Okay, so what do we get? Well, the 2 sits out front. Antiderivative of e to the u is itself. And then we're evaluating from 1 to 4, so we're going to get 2 e to the 4 minus e to the first. And if we want to distribute the 2 to make it look a little bit neater, we can write it as 2 e to the 4th minus 2e.